So let's continue our study here. We're looking at this object that's in front of the mirror, and we want to construct the image here. And so, yeah, go ahead and pause the clip and draw this one on M9. And yeah, let's see what image that we get here. If we're looking at a mirror and we're in between the center and the focus, what kind of image do we get? So go ahead and pause the clip and give us a try. When you're ready to check, you can hit play to continue. All right, so for this one, we can draw the parallel ray. We go straight towards the mirror, then through the focus. Focal ray through the focus, and then comes out straight, and the two meet right here. And this is where the image shows up. So we want to name our image, and so based on the nature, orientation, and size. So go ahead and pause the clip and do that. And when you're ready to check, you can hit play to continue. Okay, so real, it's on the shiny side, the positive side. It's inverted and it is enlarged. The size is larger than the original. All right, so how about if we have an object over the focus? So we can do this on M10. Go ahead and pause the clip and give this a try. And I'll warn you, this one is kind of strange. So yeah, just draw what you get and then we'll talk about it. Okay, so here's the parallel ray. We have the center ray. Turns out at the focus, no image is formed. It's a big blur. And so we had a chance to do that today in class where we had the large concave mirror and it's a huge blur there. All right, so what if we are inside the focus? So yeah, go ahead and pause the clip here. Go ahead and try this one. And when you're ready to check, you can hit play. All right, so we have our parallel ray. We have our center ray. And those rays are diverging. And because these rays are diverging, we know that we need to trace them backwards, and that's what we do here. So the image shows up on the negative side. It shows up on the dark side, the virtual side. So it turns out that this image is virtual, upright, and enlarged. And so, yeah, this if you have an object that's inside the focus, that's what we get there. So I had them practice in class drawing this one. If you have an object, and you could draw this, freehand draw this if you want to there. You know, if this is the focus and you have your object here versus having your object like way out here. And so yeah, go ahead and draw those and see, and we'll compare, compare those two. And when you're ready to check, you can hit play to continue. All right, so the way that this should come out is with this one, we should get, an inverted object when it's really far out. When it's closer, it should be a little bit larger. And so the conclusion here is that the image becomes larger as we move closer to the object, but it's still inverted. Now, if you're inside the focus, it turns out that, if we draw this one here, we get a very large one here, but if we're here, something like that. What I love about this picture is her hand is a virtual image. And so it turns out her hand is inside the focus of this mirror. But then if you look at like this bench or the tree or the sky, it is all beyond the focus, and so it's upside down, it's inverted. And so that's what we see. If it's upright, if it's inside the focus, but outside the focus, it is inverted. So next, what we're going to take a look at is the mirror equation, and this will help us calculate what's going on with the different objects. And in this case here, we have we have our equation for the mirror, and we have the distance of the image. We can determine through our calculation, we can determine exactly where the image is, exactly where the object is. And well, we know where the object is, but we can figure out exactly where the image should be based on the focal length and where we place it, DO. And we can use any units. Typically, we're going to use centimeters, but we don't have to. We could use any units for that. And yeah. This is also another equation here. Magnification equals HI over HO, and magnification equals negative DI over DO. all three are on your equation sheet, and they're very useful because we can figure out the magnification, and we can also find the height of the image and the height of the object. Well, we'll know the height of the object, but we'll be able to figure out how high the image should be. And so we can draw these as well as calculate these, and that's where we're moving here. So let's try this first one here. We have an object over the center, and we want to calculate, or we want to draw the image and calculate the image as well. And so, yeah, go ahead and pause the clip and give this a try. Go ahead and at least draw it first, and then we'll get the calculation set up together. All right, so we have our principal ray goes through the focus. We have our focal ray, and we get our image located there. So let's write down our variables. The focus is 35 centimeters. DO, its object is placed 70 centimeters from the mirror, so the object distance is 70. The height of the object is 28 centimeters. And so as we get started here, we can calculate where DI is. Where does the image show up? We can also calculate the magnification, and with that we can find out the height of the image. So 1 over DO, or 1 over DI plus 1 over DO equals 1 over the focal length. 1 over DI plus 1 over 70 equals 1 over 35. We can subtract 1 over 70 from the other side. So we get 1 over DI is equal to, let's get that here, 0.0143. And then we cross multiply, so DI will be multiplied by 0.0143 equals 1, so DI comes out to be 70. And that makes sense. The image is located right here at the 70 meter mark, right where the object is. Now we can find out magnification as well. We have magnification is equal to negative DI over DO. So we have negative 70 centimeters over 77 centimeters, and negative 1 is the magnification. And then magnification equals HI over HO. So negative 1 equals HI over HO, which is 28. So it'll come out, HI will come out to be negative 28. And that's what we see here. It's upside down. Same size. That's what 1 means, same size, but the negative means it's inverted. And our picture can, or our calculations confirm our picture. And that's really helpful. And here's just the breakdown of that last one. Okay, so for this one, I'm going to have you try this one on your own. Go ahead and draw it first, and then calculate it, and then you can name the image, and we'll see how we do here. So yeah, go ahead and pause the clip, and then when you're ready to check, you can hit play. All right, so here's the parallel ray going through the focus. We can draw the focal ray as well. And so it ends up here. So we have a real image. It's on the positive side, shiny side, real, inverted, and enlarged. And we should get for our distance 60 centimeters, magnification of -2, which means it's twice as big, but it's inverted. And then the size comes out to be -30.